All right. Um, we're going to revert to type a little bit just for today. Specifically, I wanted to enumerate an idea that's been developing for some time with respect to software engineering. Um, there are some interesting tangents and ways that this does connect, uh, but I want to look at specifically the idea that in order to be a successful developer or engineer, what have you, you have to learn language X, right? And sometimes it'll be language, sometimes it'll be a framework like React, sometimes it'll be something else entirely, or a tool or technology. Um, what I've found going on a couple of decades of mostly software engineering at this point is that it's less about the specific languages, which can change over time, and it's more about sort of your tool belt. And it's not just in terms of like what sort of skills and things that you can reach back and use, which of course is always the case in any profession. But with respect to software engineering, and even engineering in general, there's specific slots in that tool belt, specific roles that different languages will provide that are largely based on how those languages are categorized and how they're used day to day. So today I wanted to break down sort of the three core levels of programming languages, and then a few other caveats and a few other things that we'll mention off to the side as well. So without any further ado, I wanted to start by describing a very specific stack, as it were. And this is sort of traditionally what I have most experience in if you took like the top three languages that I've used more than most. Um, let's put C++ down here. I've also done a decent amount of Python, and I have a pretty substantial experience at the sort of lower, uh, fewer framework level of JavaScript as well. So when you sit down with a new project, for example, the typical instinct is to grab whatever language you're most familiar with or whatever language you've used most recently. All right, that being the catch, because that will build on itself and you'll get more experience in that. Um, but after a while, you start to recognize that as much as it's fun to flame different languages and to engage in those debates, that different languages actually play very specific roles. JavaScript gets a lot of hate, but it's very good for some things. Python gets a lot of hate, but it's very good for some other things, and those things don't necessarily overlap. And depending on the project you're working on, what you're trying to do, what the constraints are, and what the rest of your team is familiar with as well, there will be different trades that go into that decision that may end up with you choosing one of these options or another option or something else entirely. Uh, C++ gets a lot of hate. But for example, if you are in game development and you're not coding in C++, you will get some questions. If you're going for an interview with a AAA studio to work on engines, you will need to know C++, and you'll need to know it fairly well. So suffice it to say, all of these languages are different. They have different strengths and weaknesses, of course, and they have different roles to play with in different projects. Actually, I hadn't planned on this, but let me pull up one of the most interesting books that I've read called Masterminds of Programming. Basically, it's an interesting collection of interviews with the creators or designers of different programming languages. And what you find, in addition to sort of the entertainment that you get from, for example, Guido van Rossum trash talking the Java creators, and the Java creators trash talking the C# creators, and everyone hating on C or C++, etc. Um, one of the things you come to realize is the degree to which specific heuristics, specific use cases, and specific objectives shape the design of a language, at what level it operates, what sort of decisions are made when it comes to implementing that language. Something like LLVM, or whether or not it has garbage collection, or whether it's compiled, or like, there's all sorts of reasons to make those decisions as a language designer. And as an aside, if you ever get a chance to take like a compiler or lexing parsing class, I could strongly recommend it. It's absolutely fascinating stuff. Um, so with an appreciation for those trades, we can come back to this, right? Uh, these are not the only languages. I've probably coded in 16 languages or so. Maybe not quite so many, maybe 8 or 10 when it comes to like which programming languages I've been paid to use in a job. There are some other outliers here, but even if we just focus on these three, what we see is there are very specific strengths and weaknesses, both in terms of what the languages were originally designed to do by their creators and sort of what they've grown to do, right? Python started out as sort of a general cross-platform platform scripting language for the scientific community, but it's since grown into a very strong general purpose programming language with a very robust packaging ecosystem. Just don't ask how they're packaging the code, of course. JavaScript was created in what, 5 days or something like that by the Netscape engineers, as the legend goes. And one of the reasons it's been so successful is it has a very basic syntax that's also very flexible. It lends itself, by virtue of the UI-based use case that it had, it lends itself very well to asynchronous programming. As well as, of course, DOM interactions and a few other very healthy core libraries. So what exactly are these different levels, right? How do we distinguish from, let's call this, I don't know, do we want to come up with, we could go L1, L2, L3. We should probably come up with better names for these, but let's talk about first specifically what makes them different, right? Let's, why would you, let's say here at the bottom level, right? Let's assume we're not interested in assembly or machine code for professional purposes. We still need to, it's very useful in your career to learn a low-level language. What makes a language low-level? First off, one thing we find that these languages typically compile to platform-specific binary code, right? They are platform-specific. They are compiled. And I would argue, although this can blur the lines in some cases, one of the other distinguishing factors for the sort of first tier of languages is there is no garbage collection. You are specifically and directly managing and manipulating your memory and your memory allocations. So this, for example, is why I wouldn't quite put Go here. Go would probably be somewhere higher up, but I would put something like Zig or Rust here, right? Rust might blur the lines a little bit more because of how many guards and protections there are around memory management, but certainly in the case of something like Zig, and the rest of the C family for the most part can live here too. C# might blur the lines a bit. Objective-C, same sort of thing, but C, C++, Zig, all those things. It's very helpful in your career to know at least one language, be comfortably, you can go out and write some arbitrary tool for a given platform in a language that is platform specific and compiles to architecture specific code, is compiled and requires you to understand what's going on in memory space. Doesn't have garbage collection. One of the tricky things about languages in this category is that, although this is changing, of course, somewhat, is one of the things that you lose in addition to garbage collection is package management. And obviously in C and C++, this is a big deal. Zig is getting there. Rust has a pretty modern solution to that that's fairly well automated. You can supplant this somewhat with use of Git submodules, and then there's other sort of modern attempts to do C++ package management, something like Conan, etc. That breaks down to a couple of problems, like how you're identifying a specific package of code, how are you identifying and retrieving dependencies, including version correlation, right? Where are those coming from, and how are you building those into specific artifacts so you can perform meta operations against, like, give me the documentation for that, give me the libraries for that, link against it, etc. So that's probably enough to say about this low level here. The next we have what I would call, so if this is low level, let's say this is a general purpose. This is typically going to be defined in contrast to this, but with a few key features. First off, this is, as the name might imply, this is general purpose. This is not a domain-specific language. This is something you can use for writing arbitrary scripts or sharing interesting tidbits of useful code regardless of what the specific use case or domain is. This is probably going to come with some degree of garbage collection and other automation agnostic automation tools like a threads library, for example, something that would otherwise be specifically, you don't want to worry about which libc implementation you're using, right? At this level, you need to know, yeah, I'm going to create a new thread. Please just give me a thread. So yeah, garbage collection, other usefulness. This is probably also going to come with a much healthier and more automated package management system. So package ecosystems are a big plus, because one of the things that this level of programming language is about, whether it's Python or anything else, is just how easy it is to get things done quickly. And that comes down to, among other things, how easy it is to reuse a lot of the code that you may have used before that other people may have used to address specific solutions. Another thing that, in addition to integrating with other people's code, another thing that characterizes this level, there's typically pretty good bindings. Whether you need to expose calls for other languages or you need to wrap some other lower level library. Oh, I should also mention, like, Fortran would probably live down here, right? I specifically mentioned that because if you have like BLAS or LAPACK, there's probably wrappers and bindings at the Python level that you would need to be using to call into the underlying Fortran implementations. That's a good example. So platform agnostic, general purpose, etc. When in doubt, when there's nothing pushing you up to this space or nothing pushing you down to this space, this is a great place to typically start a project, right? Before you know specific details about what the requirements might be, this is a great place to do MVPs. This is a great place to do side projects. In general, this is probably the most likely place where, at least in my experience, you're going to be comfortable enough not to need to look up like specific documentation on switch case or how the ternary expressions are constructed, right? Python's a little bit of a special case because things like white space, sensitivity, and some of the other Pythonic quirks. But other languages I would put here would probably be things like Ruby. I mentioned Go. Sort of any other general purpose programming language that's fairly platform agnostic would go there. So, but if that's general purpose, what are we putting up here? Why would we ever use JavaScript? Well, I'm not going to call this domain specific. But I am going to point out that this higher level is usually showing up in something like scripting or behavior automation, UI, glue, binding, and extension, which is something of a so. Ignore the JavaScript piece here for a second, and I'll talk a little bit about the application of game development in a moment. But what you'll find is there's a lot of languages that live very comfortably in this top level stack where they could be used as general purpose, but they typically have pretty specific applications that are either UI oriented for defining how events are handled and passed down to other language levels, or how people can drop in scripts to extend some specific behavior or add-on or what have you. I should specifically put UI scripting here, and you'll see why in a few minutes. So let's call this like a UI scripting, basically. So you could do some sort of rough and dirty thing here, but there's probably some sort of embedded context or interpreter. And in fact, interpretation is one of the defining characteristics, right? If the compiling is specific to here, you could have some sort of bytecode or intermediate runtime here. This is almost guaranteed to be scripted, right? This other languages that could live here might be something like Lua is a great example. JavaScript, or you could probably even put something like Swift up there, maybe if you sort of step back and squint for a minute. But so if we go to the point of this conversation, at least, there are, wow, you really don't want to cooperate, do you? Sort of, those are the three. If you should have like 3 languages in your turbo that you can reach out to depending on what you need to do at any given point in time. low level, general purpose, and some sort of UI or scripting language. But you'll notice there's a few other boxes up here, right? Um, and in particular, don't think of layers as attached to those boxes because these aren't really corresponding to the same tiers. Why would we need something else? Why do we have to learn so many languages? Well, let's ditch this specific definition and examples here for a second and talk about game development. A topic near and dear to my heart. And you know what? I should probably pull up the guy that I had for this if I can remember where it lived. Sure. Let's try this. Nope, nope, maybe, nope, nope, maybe. Let's try this. Yes. Okay. So I wrote, I've done a lot of the game engine investigation and research over the years. Here's an article I had put together about sort of different evolution, stages of evolution, and what a game developer's journey is, right? So what is the most basic possible way to structure your game code? Um, as it gets more sophisticated, how does that typically develop? How are things encapsulated? How are they broken out? Um, this typically ends up being like where you go from low, mid to mid advanced level game development. So you have something that it resembles a reusable library or engine of software elements that are organized into several very specific patterns. Um, but uh, you'll recall earlier I mentioned that if you're doing like engine development at AAA or be interviewing for it, you're going to need to know C++ pretty well, right? But that's a very small fraction, and maybe some of the tool development, that's a very small fraction of the overall game development. The low-level C++ stuff is typically going into something like engine development. By definition, an engine is not a game, right? An engine might define some sort of core logic or loop and set of reusable elements, software elements that can go into making a game. So this manager guy here, for example, might be part of your engine. There may be some base model for different scene graph nodes that you can reuse, and there may be some interface that you can define out to userland, input, output, out to some individual modules. But like your lower level code, your C++ code is almost going to be exclusively in the second layer here. What that means is the actual game itself is probably going to be put together in some general purpose language, might be the same one. Just for sake of argument, let's say there's, the game is written in Python, so let's put performance to the side. Like the game specific code for this game, Bob's Woodland Adventures, right? It may use an engine that's written in C++, but like the game logic, the mechanics, the different elements and modules that are hooking into the engine and the core loop may not necessarily be down here in C++. They may be running in an environment where it's a little easier to have like managed execution. It's hard to like interrupt calls, right, in C++ when something starts failing. And extension in particular is a big one. Having your reusable interface so that this remains reusable. Most of your, like, think about World of Warcraft, for example, most of your coding for the game is going to be different from your coding for the engine. But there's another level up here. So if you go down here, there's an interpreter module, and there's scripts that can hook into the interpreter. If you've ever developed add-ons, for example, in World of Warcraft, those add-ons are not developed in C++. Those add-ons are scripted in Lua. One of the defining features of this level of language is that there is some sort of interpreter, if you recall. That interpreter is probably going to be written in another language, and it can probably be hosted or embedded. So this is where, for example, you can write add-ons or hooks or some other means of extending a specific game with unique or customizable logic or skins or behaviors or ways to hook in calls to specific events that might be published within the game itself. So what we see is sort of those three levels of languages are actually reflected very well as an example in game development. So it's still good to have some sort of useful knowledge of embedded scripting. Lua is a very popular option for that example. Um, there are other game engines like Godot that have their own scripting language, for example. But you'll see this come up time and time again. And if you want to specialize in engine development for games, then just understand that you are like the actual game is going to be the user of the code that you're writing, right? Um, most of the tooling will live here. Most of the other elements that are part of the transform that defines like the development and the build of a game, and then the runtime for all those specific mechanics and behaviors is not necessarily going to be in the engine. There will be hooks for it, and then some sort of high-level scripting for extension and embedding. Well, where does that leave us? We have those three elements. We have those three blocks, but do you really only need three languages? If you are fairly comfortable with at least one language in each of those categories, you're probably going to do pretty well. And that's very helpful, right? Think about the specific slots on your tool belt. If you have those three tools, they will take you very, very far. But, so this is like the bonus, right? Call now and I'll give you 3 extra language recommendations free. I haven't recommended specific languages for any of these. There's lots of different combinations. You can almost think of it as a tech stack problem, right? Instead of C++, Python, JavaScript, you could have Lua, Go, Zig, right? Just, I don't know, as an example. But there are at least 3 other specific examples, and these aren't necessarily specific to levels, so maybe I'll draw them out like this. So you don't necessarily get the wrong idea of languages that I would strongly encourage you to think about having some sort of familiarity with. The first is some sort of, let's call this shell scripting. This is typically platform specific. This is basically a collection of commands that you would otherwise issue from a shell. And this is very strongly oriented around automation, task automation, right? So common examples of this would be like, if you're developing on Windows, you should probably know how to write a batch file. That comes with common knowledge of like how to assign variables, what control loops are, how to write go-tos and subroutines, etc. Same thing if you're on Linux most of the time, you should know how to write a shell script. If for no other reason than this gives you familiarity with like how to automate the actual commands for the operating system and the environment that you're working with. But there's so many problems that you can just solve with a simple shell script or some other equivalent. Interestingly enough, I kind of alluded to this before. Python started out, before it grew into sort of a general purpose language, it started out in the scientific computing community as sort of a cross-platform scripting language. And it still has very strong, core module. It still has very strong use case or application as sort of a cross-platform scripting where you can write scripts that interact with the operating system and other processes in a way that's automated, fairly transparent, easy to debug, but also easy to develop in. One of the other advantages here of general purpose is one of the strengths of a general purpose language, or one of the ways to measure the strength of general purpose languages, without installing any other packages, how much can you get done just with like the core modules in the languages, right? And that's one of the places where Python really shines. Is like you can do JSON serialization and SQLite interactions and all these things with core modules that are built into a Python distribution. Like, don't underestimate that. The fact that we didn't have that for so long, like, another difference between these levels, by the way, is the difference between logical representations within like code symbol manipulation and import actions, import export, and the file representations on disk. So those are almost completely decoupled down here, right, where you have much looser namespace control and it's a much lower level. You start getting much better representations or isomorphisms between the file system and your source code because it's interpreted, right, after all, and the logical representation of symbols within your program and import export. That's one of the stronger points of general purpose as well. So shell scripting. Choose a scripting language or choose a shell, learn how to automate it, learn common control flow, etc. So that's sort of bonus number 4, right? Number 5 here is going to be intentionally vague. In this category, we're going to put something called a DSL. A DSL is a domain-specific language. We talk about, this is the opposite of a general purpose language, right? If a general purpose language is just sort of Swiss Army knife you can do anything with, a DSL is a very specific language designed for a specific context and environment to solve a specific set of problems. Common examples of this might include MATLAB. That's one I have some degree of familiarity with, specifically for like linear optimization and other interesting numerical problems to a degree. Controls, if you combine them with simulate. Scientific computing, tensor manipulation, right? MATLAB is very, very good at these kind of things that outside of Fortran, you wouldn't want to do any other language, although, you know, NumPy and SciPy are helping you get pretty close there. We'll ignore Octave for a moment. Another example of a domain-specific language is like an agent behavior language. An agent-based modeling simulation application, for example, you may need ways to define behaviors of something that's moving around within your scene. There's other like ways to combine that with declarative language structures, for example, to define what the scene is, but some sort of domain-specific language to help script agent behaviors. Agent or behavior trees, for example, or AI for NPCs in a game. There are all sorts of interesting ways to script and automate those in a way that's typically more domain specific. You could think of TensorFlow and other sort of neural network expressions as something of a domain specific language, even if they're implemented or called in other languages. There's a very specific grammar that is unique to the way that neural networks are set up and trained and configured and combined, right? So there's lots of interesting domain-specific languages, and really what it comes down to is I'm not going to tell you what domain-specific language you have to learn. That comes down to your domain. But there's a really good chance in your career you'll find at least one example of a situation where there is a domain-specific language, or it's helpful to create a domain-specific language, and you can take that and run with it. It's useful for you, for whatever your profession is, to have at least one DSL under your belt. So I haven't recommended specific languages for any of the 6 categories, 5 categories so far, right? And that's deliberate. I've given examples, but I'm going to break that rule for the 6th one, because this is sort of, you can love me or hate me for this, but the only specific language that I would demand or require you to learn is SQL or SQL. This has to do with the fact that an effective engineer, or software engineer or developer, effective engineers have a few things in common, especially with modern best practice, and one of them is data-oriented design, data-oriented development. The way that you think about how data is structured, the way that you manipulate data, the way that you interact with data determines how good of an engineer, how good of a software engineer you will be. And one of the most effective ways to learn and to grok and to reconfigure your brain around a data-oriented approach and that concept of data-oriented engineering is to learn SQL. Learn it. Be able to write a query. You don't like the implementation specific commands for like how do you look up the user table in Postgres versus Mongo. Like, don't. That's less important. But being able to write a query, being able to create a table, being able to inspect a schema, understanding how queries work and how ACID works, ACID guarantees. Not only does that map very well to a lot of the memory manipulation you may need, but simply understanding or having the grammar and the syntax to understand how data manipulations work, how data is queried, what common transforms are, how joins work, how tables need to be structured, how relational entries work, how cross-references work, how data composition works. All of those things will become much more obvious when you understand and can speak the language of databases. And NoSQL aside, even for document stores, whether it's a filter map query or anything else, or crawl or Elasticsearch, your starting point will be SQL. So learn SQL expressions, love SQL expressions, find, I don't know, Postgres or some other easy to use SQL solution that you can learn to love. SQLites, great example, right? You can just start an instance in memory right away, and there's good mappings. Not to mention mappings with like Excel or CSV or some other way to store transparent and structured data. Learning SQL will take you a long, long way. And that's the reason that's the only specific language that I would recommend. Okay, so that's probably enough of me ranting for today, especially since I broke my word and did not follow up on recent episodes with the units segment of engineering fundamentals. So let's review for a quick moment. Would recommend at least 3 languages that you learn. Low-level languages that aren't garbage collected, that are compiled. So C, something in the C family. A lot of things that go through LLVM, by the way. That's a good way to think about it. Sort of general purpose language like Python or Go or anything that's going to help you solve poorly constrained problems quickly as prototype, right? With a large ecosystem of packaging. Some sort of UI or scripting language to help automate and glue, asynchronous events or event handling or other UI interactions. Obviously, by the way, there's specific ways that these can work together. There's ways for, in Python for bindings to call C code, many different ways. In fact, there's ways to share behavior and data between, front end and learn how fetch or operates, learn how REST works, WebSockets, etc. But once you have specific choices of those languages, you'll be able to investigate specific ways that they can interrupt, both in terms of calling behavior, invoking behavior, responding to events, and passing data back and forth. Right? Those are sort of the 3 fundamental interrupt commands. And then as the extension, you should really learn a shell scripting language. You should really learn some sort of domain-specific language, and you should really learn SQL in some form or another. So 3 plus 3, enjoy. Go grok the wonderful universe of programming languages, and I promise we'll get back to more engineering next time. Take care.